So here, the procedure-oriented paradigm, this is not the paradigm that I want to teach. Here, the paradigm means is kind of style or kind of trend or how we did things, how we code like things in like here 70s and 80s, right? In 70s and 80s, what we did is kind of boundarized, simplified, and decomposed and grouped by using the procedures, right? So if you want to do this anti-analysis, we had to do like counting, and we had to do like probability calculation, and we wanted to do like multiplications, etc. Right? Means that we boundarized, and we simplified, and we decomposed, and we grouped these functions, right? And we created these things as a functions. Like in 70s, the program looked like this. The procedure-oriented, In the procedure, sorry about that. Oh. Okay. So procedure-oriented design, what happened was building bunch of the functions. Like this. This is kind of similar to what you did in the offline classroom. We made many functions to calculate probabilities and sentiment analysis, like that. So we had many functions. If you are trying to make this, if you come up with these functions, and these functions have many purposes. Like users want to use this as login purpose, right? Sometimes this web service want to use these login functions and so forth. So there were many kind of these interactions between functions. So if we go back to the offline classroom, one of the functions that you created was run analysis, right? In the run analysis, you used count functions, and you used probability counting. You created a function of finding words in review X, and so forth. Many functions were used, and these were kind of intertwined several times, so that can build up as a one single big function. Is this kind of efficient programming design? Actually, it's not. So after 70s and 80s, people were building so many functions for a certain purpose, and it has been used by many different entities, like the users, like the web services, or like this. And then what people turned the programming style into is more kind of simplifying and grouping way. So procedure-oriented design was getting more complex by making many functions. So they want to create another concept that collect and that group the functions and data as a one single entity representing a real-world entity and make things simpler. And actually that is called object-oriented paradigm. Object-oriented paradigm view is like the 80s, 90s, and nowadays, right? We want to boundarize, simplify, decompose, group. That's same. But here, previously, what function or procedure-based focused on was the verbs, such as count, or find, or calculate. And we want to change the concept into this, like entities. And this is more like nouns. Okay? And nouns means like the analyzers or reviews or data sets, etc. So what we did is that we changed our views from the calculations, count functions, the verb-based, the action-based view to the entity-based view, right? You might not understand what I'm talking about at this moment, so this is more illustrative example. So now, rather than building bunch of functions, what we are doing is grouping the functions. We still create the functions, but now we group them. We group them and now we group them into real as a class. This shows class and this shows functions. And these are the properties or the values. Okay? Variables and also variables. What we are doing now is that we group functions and we group properties, variables, and we want to represent it as a real-world entity, like the customer and transactions and banking. For instance, if we go back to the sentiment analysis example, what we want to create is like this. We want to create a review, right? And we want to have words in review, right? And we want to get words of a single review rather than having a find word for a single for a function that is out there which is not kind of grouped, right? We want to get words like the get word indexes and so forth. And what you want to do here is analyzer. And we want to have like these data sets. Okay? And we want to have like calculate props or the count positives and so forth. So previously the functions were out there. Functions were out there like the get words and calculate and count and the find index. These were out there. Now what we are doing is that we group them and put it in some classes so we get more organized. And related data sets were included in the classes, right? So these are ways to make things more boundarized, simplified, and decomposed and grouped. Okay, so this is called object-oriented design, and this uses classes. And classes is a collection of properties and the methods. And properties is equal to like the variables. And methods is equal to like functions. Okay? So these are the things that we are doing. So again, what are the classes and the instances? So classes are the schematics. This is called class, and this is a schematic. Okay? And this is realized, constructed, buildings this is the instantiated instance. These are called instance, and also this procedure is called instantiation. Okay. So class is a result of design and implementations, and instance is a result of executions, and it's a realization. Okay. This corresponds to real-world entities like this, and this corresponds to design. Okay. So for instance, if a customer would like to have ID and account numbers like this, we set it up as like the login and request withdrawal, confirm security card. These are all the actions that customers can do, and these are the data the customer should have. And when it's instantiated, we can, by using this schematic, we can make different individuals as instances. And first one is the ID John, account number 123, ID Park, account number 456. These are all coming from the same class customer, but its data inside ID and account number are different because these are all instances and personalized items. Okay. Then what you want to do is making these schematics. Of course, in the construction field, like civil engineering, we have this standard, how to draw a blueprint. And after you graduate, after your graduation, what I'm envisioning is that you are going to be in kind of mixed with teams of the software development team, and what you are going to provide is your expert knowledge about the operations research and statistics and so forth, right? But your knowledge is going to be carried out or packaged by a software, and eventually what you are going to do is mainly design, and you are going to do some coding. And you have to learn how to communicate with your friends who are going to implement and package your ideas as software package. And this communication language is going to be the UML. Okay. So in the civil engineering, we have these standards. In the software development field, we have a certain standard called UML, and it's coming from the OMG group and so forth, right? So what we are going to learn throughout this week is how to draw this diagram. Draw this diagram is going to be your next exercise. Okay, so what we are going to learn is the UML for software design for the rest of this week. Okay, and I'm going to continue this topic in the next part of this week too. Thanks, and just my 2 cents. 2 cents means like the my advice for you who are struggling in the programs and coding. Try to type in every MATLAB code. What you see on the slide sets. You can just pause it and you can just type in. Most of them will work because we tested it. If it doesn't work, please ask me or TA, and we will try to help you. And at the same time, I'm going to upload some of our offline course materials on the web so that you can try that at home, right? So the best way to learn programming, coding, and being successful in this course is that you really have to type in. If you don't type in, really there is no way. Okay? So good luck and learn your MATLAB right now. Okay.